Welcome to our last lab of the semester, speed of sound. Now, let me just take the sound off right now so you won't be bothered by it. Here is the tube that we're going to use. It's a variable length tube. All that means is I put water inside of it and I can move the water level up and down. Now, how do I do that? I take this cup, which is attached to it. If I move the cup down, water comes in the cup, it fills up the cup, and the water level goes down. If I move the cup above, the water level goes up. So it's quite simple. And there's a little scale on the side that we're going to read off the distances of resonance. Now I have a function generator attached to a speaker. Now, I've modified it slightly. Instead of using tuning forks, it's a little hard to do this with one person in and actually taping it. So for convenience sake, instead of tuning forks, I've put a speaker. Now the reason why there's all these alligator clips on there is because the speaker is not in a box and it's resonating. So whenever I turn it on, it makes this annoying buzzing sound. And I'm just dampening that this whole metal frame is oscillating. I'll actually show you because it's actually an interesting physical point of view. So watch what happens when I start taking off these things. You're going to hear this awful buzzing sound. You hear it? Oh my God, it sounds like... Ah. So what I'm doing by putting these things in is that I'm dampening the metal oscillation so that only the speaker is oscillating. I could have done that by holding it with my hand, but I can't hold it with my hand. So now that's a much nicer tone. So I'm going to put it at 350 hertz initially, and we're going to see where the two resonances are. So how are we going to do this? Well, let me just move up my little stand a little bit closer here. Sorry, I should have done this before. Now, let me move the wires out of the way here so you can see the scale. Now listen really, really, really carefully. What I'm going to do is I'm going to move the water level down and listen to any change in the tone. Okay, so I'm moving the water level down. Did you guys hear that? Let me move it up again. All right, you can't see the water level. I have to move the iPad up a wee bit, so let me put it on this little pedestal so you can see the water level and hear at the same time. There we go. Now, it's kind of close to its resonance now, so water level goes up. Now water level is going down. Oh, did you hear that? It was a little bit extra. So it's right around 23, between 22 and 23. So let's get three values of that. Let's get the first value going down, and I'm going to try and get the point where it's the loudest. It looked like 23.5. Now let's go up again. 23.3. 23. All right, so I got three values of the resonance. Average them out and place them in your data table. So that's one position of resonance. What we're going to do is find another position which is further on down the tube. So in this case, it's going to go further down, so I'm going to try and put it like this. All right, so you can see the second position of resonance. So let's move it down and listen carefully. We're going to hear a loud sound. Okay, that's the first one. I'm going down. Hopefully the water won't fly out of my cup. It's almost there. Oh, there it was. I heard it. This is a little bit smaller, but it looks like it was around 73. Hold on. Let's go back up. Right. 72 and a half? Okay, so let's go up again here. $73. So 72 and a half, 73. Let's go down one more time. 72. So average those two out. Now, so we have two positions of resonance. Average them out, subtract the two together, and you will have half of a wavelength. So multiply that by 2 to find the wavelength. The frequency, again, is 350. So to find the velocity, you multiply 350 hertz times the wavelength. So again, the wavelength is twice the difference between those two resonance positions.